Hi, fans. I'm the PC Expert Amateur, and this is the second and most likely final video I'm going to be doing, or actually third technically, video that I will be doing on comparisons of different types of barriers, filters, meshes, that kind of thing. And this time, instead of using the high-powered fan that I used before from a room, I can't remember. I can't say the dang name. Anyways, what I'm going to use instead is the Fexidon Tech M2-12AB PWM fan, and it's a as far as like its power for airflow and static pressure, it's completely average. So it's it has an interesting effect for the lighting. Oh dear, and that's it. There's nothing else remarkable about it. So I've used this with all of the different barriers that I have, which is this is the red waved mesh. As you can see, there are these grooves in it, and that impact, and it's also not flat. And this, the grooves especially impact the way the air is distributed. And there's this one, which also is not flat. It's got that rounded area there. And there's this honeycomb, which is the 3D printed one. And on this side, it's textured. And on this side, it's mostly not textured. And then I also have this one, which has 6 rings and it's plastic. I have another one. I didn't keep it out because I put away the other fan, the Emerja. There it is, Emerja fan, and the grill went with that. But I also tested that. It's a metal one with 8 rings instead of 6. So it doesn't have this extra stuff around the sides. It's just 8 concentric circles with the little things going on with an eyelet to mount it. And then I have this one, which is a Silverstone product. I don't think they make it anymore. It's a combination of a relatively fine mesh, and then the honeycomb on the other side, which if the tests that I did yesterday are correct, then that honeycomb is too small. And then there's this one, which is very, very fine, and it's extremely constricting for airflow. It's not a good choice. And finally, there's this one that has that kind of a spiral grill on that side, and it has the 6-ring grill on this side, and in between it's got a thin layer of foam. And so the air has to force its way through the however many layers of bubbles there are actually in the foam, which definitely significantly impacts airflow. Now, so what we should be seeing here, if this has got a proper controller, is we will see that the more restrictive the airflow is, like with these two, the higher the RPMs will be above what it would be without any kind of a barrier. And I've got that in the chart too, of course, just like I did yesterday. So I hope that that's all clear. They say that their airflow is supposed to be 62 CFMs or cubic feet per minute, plus or minus 10%, and the air pressure is 1.2 millimeters of water. Now I'm going to show you the least important one first, which is the one that shows the RPMs, because this one lets us know whether we've got a good controller in this fan or a bad one. Which is to say, not that the controller is damaged, it's just that it doesn't have that function where it speeds up the RPMs to compensate against the pressure. So we can see that the ones that produced, and it's kind of weird because on the one hand, for example, very fine mesh, we have a very low RPM here at the top, 1740, versus down here, 1840. It's 100 RPMs of difference. Not a huge difference, probably not significant, but it's a little bit weird. And I think that the reason is because the fan has to work harder when the mesh is in its way with the air. I mean, in the way of the wind. as opposed to pulling the air in, there's less resistance somehow. That's my theory. And we can see that the coarse mesh on intake, 1730. But if we look at it how it is on exhaust, 1910. So there's a huge difference in terms of the pressure that the fan is fighting between intake and exhaust. And so on and so forth. So you can pause and explore this in more detail. But the range from 1730 to 1950 isn't terribly significant. So let me move to airflow, or I'll just go to pressure differential first. No. I lied. All right. Now, if you look at the RPM column, you would think that all the fastest RPMs would be on one side or the other, but it's all mixed up. You see 1,700 fans or RPMs up near the top. You see them in the middle. You see them in the bottom. The only thing you don't see in the bottom and a little bit but you do see it in the middle and the top, is the 1900s. So it is interesting that usually the airflow will be worse when it's an exhaust in the exhaust position the barrier is, and yet sometimes we get these other ones with the very fine mesh, which is a really bad choice. And yet the thin foam, it tends on average to be bad. You know, we see it in the worst position, and then several points down there are two more that are both at 1950. Go a few more down, and it's at 1800. But the difference in airflow is what we want to look at here. So we can see that the thin foam with the mounting grill reversed only produces or allows for 78 CMHs. And then the very fine mesh, it's basically the same as 79.2. The coarse mesh, which is a little bit surprising, only got 88.8 on exhaust, and then the very fine mesh is back again on intake at 95.4. So we can definitely say without any question whatsoever that the very fine mesh for airflow concerns is bad either way. And then we look at the Silverstone fine mesh with honeycomb on exhaust. It doesn't matter which one. There's almost no difference between the two airflows, 100.2 and 0.8. But if we look at it on intake, then we see 138 and 140.4, which are not significantly different, but that shows us that is fine on intake, not so much on exhaust. And then the thin foam on intake with the grills on both sides, 102.6, 107.4, not really a significant difference. So we've got 3 out of the 4 thin foams doing very, very poorly. And then the last one is several more down there at 139.8. I don't know how it got that far down the list, but it's a little bit confusing to me, and I wonder if maybe I made a mistake somewhere along the line. But the red one, the red wavy mesh, that one it gets an average score on exhaust, but on intake it gets an above average score. So we go from 112.8, which is on the lower end of average, up to 145.2. So that's a significant difference. And then carrying on, the coarse mesh, there's that, and then the 6-ring. We finally see the 6-ring. Now, I had predicted that the 6-ring would be really bad, but it didn't turn out to be as bad as I thought it was going to be. And this is the first of the 4 6-ring ones. So this is the worst. On exhaust, 136.2. If we have it on exhaust reversed, 140.4. So that's not a significant difference. So it's just not as good. I mean, it's still above average, but it's not as good on exhaust. And then if we go to the intake ones near the bottom there, we see that 151.8 and 156.6, not a significant difference between them, but a significant difference from the previous ones that are on exhaust. And then finally, the 8-ring metal grill that is very, very commonly seen on fans, 149.4 versus 158.4. That's not much of a difference. So if you are just trying to keep people from sticking stuff into the fan by accident, like fingers, the 8-ring metal grill is excellent. Now, how do all these compare? Well, look at the bottom of the list. None. No barrier, 1760 RPMs. So it's not straining itself as much as most of the other ones. Like, yeah, except for the red wave mesh on intake, that was marginally smaller, 1750. But the loss of airflow from no barrier to the 8-ring metal grill on intake is almost 10 CMHs. So that's kind of meaningful. Not really, really majorly meaningful, but it is interesting to see that loss. I had not expected to see that much of a loss. Now, let's finally look at the pressure differential. And we can see here that in this case, the lack of barrier did not actually prove to be the one that would produce the best pressure differential from 0 to maximum, the way I do it. But we can again see that the very fine mesh on intake is the worst, followed by the thin foam, and then the Silverstone on intake, and then the other thin foam on intake, and we got coarse mesh on intake. So for pressure differential, and this is not as important as the airflow column, okay? You just keep that in mind. It's more for an informational thing, because pressure differential is a combination of different things, including both static pressure and airflow. But we can see here that the 8-ring is one of the best options, whether it's on an intake or exhaust. And the 6-ring is only great on intake if you have it mounted the way it's supposed to be mounted, not reversed. And otherwise, it's not as good. But again, these numbers, when we go from 69 to 67, that's not significant. So you could happily say, well, I'm going to put it on exhaust, and it would be okay. It would not be great, but it would be okay. So I think what I'd like to do now is just put up the specifications in a comparison format, so you can see the difference with the regular fan and the high speed fan or the high power fan. Okay, so looking at this one, what we see here is there are some definite trends. For example, the best choice in both cases for airflow, because airflow is the main thing here, is not using a barrier. But if you're talking about intake, you need to have a barrier to keep fingers out at the very minimum, and if not fingers, then to keep dust out. So what are your options? Well, if you don't care about dust, if you're going to clean the dust out periodically so it doesn't impact your computer much, then the 8-ring or even that crappy 6-ring plastic grill is something that you should get rid of. Or sorry, not get rid of, use. But also, we can see that the red waved mesh on intake is a good choice, and the in both cases, and the plastic honeycomb grill on intake is a good choice. So a little bit counterintuitive, perhaps, but the majority of these are really good CMHs. Obviously with the Amarunja 120x38 fan, that's a very powerful fan, so everything looks great. But what we're looking for here is where the loss of airflow is significant, between reverse to normal, between intake and exhaust. I'm not a mathematician, So I'm going to let you guys see what you figure out. Put it in the comments, your observations about this. And the only thing I guess that I would say that from the coarse mesh on intake on the right here for the Fexodon Tech, all the way down, all of those airflow numbers are great. And there's not a huge difference between them. Yes, it's nice to have 158.4 versus 132.6, but all of those are acceptable numbers because those are all above average. They're, it's pretty good. But the ones above that coarse mesh on intake, we can see definitely those are ones that we should probably think about. Well, we don't want to really do that. So most of the choices are available. I think all of them actually. But there are definite ones that stand out as being the best choices. The 8-ring, the 6-ring, and on intake, the red wave mesh, but not exhaust. And the Silverstone on intake is better for a lower fan than the average fan than the high-powered one. So I hope that this has helped to answer questions about different types of barriers. I wish I had more that I could have tested in this, but I don't. So thanks for watching, and I hope that you have a great day. If you would like to help me and get something out of it by helping me on a one-time basis, you can go to my eBay channel, the PC Expert Amateur, where you can purchase the items that I have on sale there. There are lots of keyboards and mouses and some other items as well. I've got cable organizers with power supplies and a bunch of other stuff, a nice variety of things that I have reviewed in the past and I no longer need, and I need to make space. Plus, I also need the money. So if you want to do that, the information's on the screen.
I need to ask for your help. Things have been challenging. Whose life hasn't been challenging lately? So if you can please help me out by liking, subscribing, sharing, commenting, and turning on notifications, that would be really, really super. Also, if you'd like to help me financially and you can't afford to, you can do a super thanks on my Glenn's Fast Reviews channel, or you can become a member there. Or if you prefer, you can go to patreon.com/GLENNMII and become a member there instead. Also, I'd like to give a shout out to Bleeping Computer for their support of my channel. If you need resources for computers, for getting rid of malware and learning about cybersecurity and stuff, Bleeping Computer, BLEEPING computer.com is a great resource. Thanks so much for watching and have a great day.